We're going to sketch the graphs of two polar equations. The first equation is r equals f of theta equals to 1 plus 2 times cosine of theta. And the second equation will be r equals g of theta equals 1 minus 2 times cosine of theta. We'll start with the first equation. We'll need two results. The first result is a trig identity. Cosine of minus theta is equal to cosine of theta. This is true because cosine is an even function. And the second result we'll need is how to determine when the graph of a polar equation is symmetric. So we're looking for symmetry with respect to, so WRT stands for with respect to the x-axis or the polar axis. And the polar axis is just a line, theta equals 0. So let's see how we can detect symmetry with respect to the polar axis. When a point is on the graph, and let's suppose the point is here with polar coordinates r theta, this angle here in the counterclockwise orientation is theta and the length is r. If we have symmetry with respect to the line theta equals 0, then we should have a point on the opposite side of the line, and this angle is now measured in the clockwise orientation, so it is minus theta, and this is still r. Its polar coordinates are r and minus theta. So if r equals f of theta is the equation, plugging in minus theta for theta into f, if that gives us the same value of r, then we have detected symmetry with respect to polar axis, or the line theta is equal to 0. Now our equation, the first one, is r equals f of theta equals 1 plus 2 times cosine of theta. Now let's plug in minus theta for theta. This is 1 plus 2 cosine of minus theta. By result A, cosine of minus theta is same as cosine of theta. So this is 1 plus 2 times cosine of theta, and that's f of theta, which is the same as the original function. And therefore we found symmetry with respect to theta. The line theta is equal to 0. That means all we need is to sketch the graph on one side of the polar axis, and we get the second part on the opposite side by symmetry. So let's plug in a bunch of points in the first and the second quadrant to get a good idea what the graph will look like on one side of the polar axis. This is theta, this is r. We'll start with theta equals 0, pi over 6, pi over 4, pi over 3, pi over 2, and then 2 pi over 3, 3 pi over 4, 5 pi over 6, and finally pi. Plugging in 0, cosine of 0 is 1, 2 times 1 is 2, plus 1 gives us r value of 3. At pi over 6, cosine is square root of 3 over 2 times 2 is square root of 3, so r is 1 plus square root of 3. At pi over 4, it's 1 plus square root of 2. At pi over 3, cosine is 1/2 times 2 is 1 plus 1, that gives us 2. Cosine of pi over 2 is 0 plus 1, r is 1. At 2 pi over 3, cosine is minus 1/2 times 2 is minus 1 plus 1, r is 0. At 3 pi over 4, we get 1 minus square root of 2. Notice that this is a negative number. I'll put a minus here to indicate that that's a negative number. At 5 pi over 6, we get 1 minus square root of 3, which is also negative. And then at pi, we get 1 minus 2, which is minus 1, and clearly that's negative as well. And now we can plot these points and make a good sketch of the part of the graph on one side of the polar axis. So we'll just make our grid like this and indicate various rays for different angles. This is theta is 0, this is theta equals pi over 2. We'll start here. This is pi over 6. This will be pi over 4, pi over 3, and over here this will be 2 pi over 3. This is 3 pi over 4, and this ray will represent 5 pi over 6. So we are ready to sketch. At 0 we have the largest value, which is 3. At pi over 6 we have 1 plus square root of 3, which is smaller than 3. At pi over 4, 1 plus square root of 2. At pi over 3 we have 2. At pi over 2, 1. So far our graph looks something like this. Now between theta equals pi over 2 and 2 pi over 3, we have value at pi over 2r of 1, and at 2 pi over 3 it is 0. So the graph spirals down between these two angles to the origin like this. Now at 3 pi over 4, the value is 1 minus square root of 2, which is negative, and that means the point is not in the direction of angle 3 pi over 4, but in the opposite direction across the pole. And 1 minus square root of 2 is a fairly small number, but it's somewhere over here. And then at 5 pi over 6 we have a negative number as well, so it will be on the opposite side again, which let's say would be over here. And at pi the value is minus 1, so we go 1 unit in the opposite direction. It takes us right over here to the point 1, 0. And so now we can sketch the rest of the graph. It comes in through like that. And of course we have the direction with which the graph is created, in the direction using increasing values of theta. Now let's use symmetry to get the graph on the other side of the line theta equals pi over 4. For this part of the graph that's below the line, we'll get a part that is above the line that looks very similar. That's called the inner loop. And then for the part that's above, we're going to get this piece here that's called the outer loop. Now the graph has a name. It's called a limacon, and it's written like this. And this is an example of a limacon with an inner loop. You can try to we have to make sure that we got all the points on this graph. You can try plugging in some other values of theta, and you will see that we're simply going to get points that are already on this graph. So this is an example of using symmetry, and the reason I started looking at symmetry with respect to the line theta equals 0, or the x-axis, is because the graph had, or the equation had, cosine of theta in it, and that's what gave me the idea to check symmetry with respect to line theta is equal to 0. If that was sine of theta, we'll be looking at symmetry with respect to the y-axis, or the line theta equals pi over 2. Now let's go to the second equation. The second equation that we were looking at was r equal to g of theta equals 1 minus 2 times cosine of theta. Now we can do exactly the same thing. This graph will be symmetric with respect to the line theta is equal to 0. We can plot a bunch of points, get half the graph on one side of the line, and then get the other half by symmetry. But what I want to do here is show you how we can get this graph by using another feature of polar equations and polar graphs. So when we know the graph of r equals f of theta, when we know this graph, then the graph of f of theta minus alpha, where alpha is a constant value, usually positive, of its alpha radians, the graph of f of theta minus alpha is obtained from the graph of f of theta by rotating the graph of f of theta in the counterclockwise direction by alpha radians. So we know the graph of r equal to f of theta equals to 1 plus 2 times cosine of theta. Now let alpha equal to 180 degrees or pi radians. And look at the graph. Let g of theta equal to f of theta minus alpha or minus pi. And we're going to see what the equation is, and once we see the equation we'll be able to use the graph of f to sketch the graph of g. So this is equal to 1 plus 2 times cosine of theta minus pi. And now let's use the trig identity. Cosine of a minus b, which is cosine of a times cosine of b, plus sine of a times sine of b. And so this is equal to 1 plus 2 times cosine of theta times cosine of pi, plus sine of theta times sine of pi. Now, of course, sine of pi is 0, so this is 0. Cosine of pi is minus 1, and then the resulting equation that we get is, so this is equal to 1 times 2 negative cosine of theta, which is 1 minus 2 times cosine of theta. That's the second equation that we wanted to graph. So we obtain the graph of a g of theta equals 1 minus 2 times cosine of theta from the graph of f of theta equals 1 plus 2 cosine of theta by rotating the graph of 1 plus 2 cosine of theta 180 degrees or pi radians in the counterclockwise direction. Of course, when we are rotating 100 by 180 degrees, with this graph, it doesn't matter if it's clockwise or counterclockwise, but in other cases it does matter. So let's go back and get the original limacon. This is theta is 0, and this is theta is equal to pi over 2. So the original limacon looks like this. That's the outer loop, and this is the inner loop. This is a graph of r equals 1 plus 2 cosine of theta. And now, by rotating this 180 degrees in the counterclockwise direction, we get the second graph. Theta is 0, and theta is equal to pi over 2. So that graph will look something like this. And here is the inner loop. So this would be minus 3, and this is 3, and that's 1, and that's minus 1. This is the graph of r equals 1 minus 2 times cosine of theta. As I said, we can always get this second graph by using the same technique that we obtained, that we used to get the first graph, that is, first showing it's symmetric with respect to line theta is 0, and then plotting some points and getting half the graph and getting the rest by symmetry. For more videos, visit www.mathprepvideos.com.